Hello, this video is on simplifying square roots. If you want to simplify square roots, then my advice would be that you write this at the top of your paper and you're going to tell what they are. So 1 squared is going to be 1, 2 squared is going to be 4, 3 squared is going to be 9, 4 squared is going to be 16, 5 squared is going to be 25, 36, 49, 64, 81, and 100. Now, the reason why you want to write these is when you do your square roots here, you want to see if any of these numbers go into your square root evenly. If it does, then you want to write that down first and then put down what this number is times whatever else it is to make it equal 72. So for example, square root of 32. If I come along here, I could say 9 goes into it, but I can also say 36 goes into it. So what I want to try to do is find the largest square root, if possible. So the square root of 72 would be the square root of 36. So I'm going to put this number first times 2. 36 times 2 will give me the square root of 72. These are both up underneath the square root sign. Now, when I take the square root of 36, I end up with 6, which is no longer under the square root. So once you take the square root of a number, it's no longer under the square root. And then I'm left with the square root of 2 still up underneath the radical because I wasn't able to take the square root of that one. Sometimes you might find a smaller square root, and then you have to simplify it maybe a couple of times. So it's like fractions. You got to keep on reducing until you can't reduce anymore. So if you happen to say it was the square root of 9 times the square root of 8, notice again, I put the 9 because that's one of those numbers up there. I put that first. So the square root of 9 is going to give me 3, and I'm left with the square root of 8. But the square root of 8 has a perfect square in it, which is 4. So I have to reduce that down. So I have 3, which is outside the radical, times the square root of 4 times the square root of 2. But the square root of 4 is going to give me 2, so I have 3 times 2, and I'm left with the square root of 2 up underneath the radical. So 3 times 2 is going to give me 6, and I still have the square root of 2 because I wasn't able to take that. So yes, it's a lot more work, but it's just like fractions. You keep on reducing until you can't reduce anymore. So this one gave me 9 times 8. I took the square root of 9 and got 3, which is no longer under the radical because I was able to take the square root, and I was left with the square root of 8. But the square root of 8 had a perfect square in it, which was 4 times 2, and my 3 is still out front. I took the square root of 4 and got the 2 times the 3 that's out front to give me 6, and I'm left with the square root of 2 still up underneath. Here's another example. 18. 18 is going to give me the square root of, does any of these numbers up here go into 18 evenly? Yes, 9. So 9 times 2. And I can take the square root of 9, which gives me 3. That's why I put that first. And I'm left with the square root of 2 up underneath. Now, sometimes some of you might go to your old ways and not look up here at these numbers. So if you happen to be one of those people and you happen to get lucky, like if you said 6 times 3, if you break these down as far as you can into prime numbers, 6 is going to be 2 times 3 times the 3 that was there already. Well, when these are all up underneath square roots, if you have 2 of the same numbers, then you can bring that out front. You got to have 2, though. It's like a marriage. You got to have 2 of them in order to bring it out front. So I have 2 3s here, so I can bring the 3 out front, and I'm still left with the square root of 2 up underneath because that one didn't have a date where it wasn't married, so it still stays up underneath the square root sign. So 3 I had 2 3s, so I can bring that out front, and I'm left with the square root of 2. This is if you happen to do your old ways and don't look for perfect squares with one of those numbers up top there.